Hey everybody, it's Mr. Carr again. Today we'll be talking about 12.3 day 1. Okay. What we're going to be focusing on is what's called general angles and evaluating our trigonometric functions of those. Okay. This is going to be an introduction to everything with this. So if we're going to find values of our trigonometric functions for what's called our general angles, and then we're also going to be able to use our trigonometric functions by finding reference angles. Okay. So what do I mean by general angles? General angles are going to be drawn like this. If we start with a coordinate plane, with a circle centered at the origin. So I'm going to try to draw it nice and big here. Okay, and we'll make sure that's nice and centered there. That looks good. All right, so we drew the circle with that around the origin. Mark a point XY anywhere on the circle in the first quadrant, not on the axis. So I'll make that point right there. If we draw a segment to the center, I'm going to mark that R for my radius. Okay, from the point XY, we're going to draw a segment that's straight. Whoops, I didn't want to erase anything. Draw a segment straight down to the x-axis and make sure it's perpendicular, making our right triangle. Now notice with that right triangle, if this is x and y, then that means that's x in that direction and y in that direction. We're going to label the angle that's between the x-axis and our radius there is theta. And now let's talk about our 6 trigonometric functions. So on this kind of a circle here, we can evaluate the sine of theta, the cosine theta, the tangent theta, the cosecant of theta, secant of theta, and cotangent of theta. We're going to evaluate all of these from just this diagram. Okay, so if you notice the sine is opposite over hypotenuse, in this case, that's going to be y divided by r. Cosine is adjacent divided by hypotenuse, so that's x over r. And then the tangent is opposite over adjacent, so that is y divided by x. Okay, so I'm just going off of this, that there's opposite, and that's a hypotenuse. Okay, that's for sine, adjacent over hypotenuse, and then opposite over adjacent. When we do our reciprocal ones, don't forget, those are just flipping them. So that means that's going to be r over y for cosecant, r over x for secant, and then x over y for cotangent. So these little ratios here, these 6 ratios are going to be helpful for when we do our modeling with our general angles. Okay, it's going to help us evaluate our different trig ratios based on something like this. The terminal side of theta in standard position contains the point 8, -15. Find the exact values of our 6 trigonometric functions of theta. So first thing I'm going to do is I'm going to draw it out. Okay, so this is x and y right here. So I've got 8, -15. So it's going to do something like, we'll say about right here. Okay, so that's 8, -15. In terms of drawing that triangle in, that means that's an 8 and that's a 15. The thing I'm missing is the radius. So I'm going to do that as r squared is equal to 8 squared plus 15 squared. That's 64 plus 225. That's going to be 289. And then when I square root that, I get r is 17. Okay, so that is my radius in this case is 17. Now, I can now set up my sine, cosine, tangent, and then cosecant, secant, and cotangent. Okay, so think back to where we saw in the previous screen. Without drawing out the diagram, I could just go off the fact that sine is y over the radius, cosine is x over the radius, and then tangent is y over x. And then all the other ones are just reciprocals. Okay, so the sine of theta is y over x. Now, in this case, since y is in the negative direction, that's -15, then that can be a -15 over 17. Cosine is in right here. It's in the positive direction. Its x is 8, but still over the radius of 17. And then the tangent is y over x, so that's going to be a -15 over 17 there. Oh, sorry, not 17. Oops. -15 over 8. Okay, so that's where we're going off of that one. Again, the reason why we have negatives here is because this is -15. Even though in terms of the triangle, it's a +15. Triangles don't have negative side lengths, but in the direction on my coordinate grid, it's then going negative. Cosecant. is going to be the reciprocal, so that's just negative 17 over 15. Secant's the reciprocal of cosine, so that's going to be a positive 17 over 8. And my cotangent is going to be the reciprocal of this one. It'll be negative 8 over 15. Okay, and again, we could still use it in terms of this is x over y right here. Okay, so that is x over y. This is r over x, and this is r over y. We could have done it in those terms as well. All right, but that's where we're going to, like, we're modeling this in the coordinate grid, finding that missing radius or whatever missing piece we might have, and then we can set up with our ratios from there. The other thing we're talking about today is what's called quadrantal angles. This is any angle whose terminal side is on an axis. So we see right here, the very first one is just 0 degrees or 0 radians. As a point on the coordinate grid is just whatever the radius is, comma 0. Okay. This one is 90 degrees or pi over 2 radians, and that's 0r. Okay, so whatever the radius is, it's going to start from 0 in the x and go up r. Here we got negative r, 0. That's for 180 degrees or pi. And if I go all the way to here, that's going 0, negative r. And that's 270 or 3 pi over 2 radians. So those are about their positions. Again, quadrantal angles are ones where it's on an axis, either positive or negative x or positive or negative y. So how does that change a little bit what we're doing here? We can still do this in terms of our x and y idea. So here again, we're going to set this up. 0, negative 2 is down here. Okay. So that's my x, y. So y in this case is negative 2, x is 0. But I can also recognize that because it's going down there, my r has to be 2. We don't talk about radius as being a negative or positive because it's just the length of that radius of the circle. So r is just going to be 2 in this case. So if I set up my 6 ratios, I'm going to start with cosine, tangent. Okay, I'm going to set them up like I did before with the values. Sine is y divided by radius. Cosine is x divided by radius. And tangent is y divided by x. Cosecant is r divided by y. Secant is r divided by x. And cotangent is x divided by y. So that's what I'm going to do here. I'm going to do the same exact things with these numbers. So sine of theta is y over r. Y is a negative 2. Radius is 2. So that means my sine of theta comes out to a negative 1 when I reduce that. Cosine is x divided by r. So that is 0 divided by my radius of 2, which comes out as 0 in the end. Okay. Tangent, however, if I do y divided by x, y is a negative 2, x is 0. What happens when I divide by 0? It's undefined. Okay. So we actually get no answer here for this one. It's undefined. Then I look at my reciprocals. Now, I could have just gone off the other numbers, but I'm going to go ahead and still model it with my r over y. So that's going to be a 2 for my radius, and y is a negative 2. So I come out to a negative 1, which makes sense, because if I take negative 1 and do the reciprocal of that, that's still a negative 1. Here I've got my radius r is going to be 2 divided by my x value, which is 0, which is, hey, undefined again. Okay, that is undefined because we cannot divide by 0. X divided by y. X is 0, y is negative 2. That comes out as 0. So cotangent is defined as 0 in this case. Okay, so be aware that if we ever divide by zeros, that's going to create an undefined scenario there. It's not possible. All right. So don't forget, when you are drawing the shapes in and drawing your reference angles, probably should talk about this earlier, but you have to make sure that you're drawing it between the x-axis and the radius. Okay, so for the example here, every time I draw my reference angle, it's kind of creating a triangle like this. That's how I would always draw my triangles. I draw my triangle, my reference triangles to the x-axis here. Okay, so what that means is if I want these reference angles from this case, we got to be aware of how they compare to the angle that we're given. Okay, so for example, that one's straightforward. The theta is just the same as my reference angle. That's my theta prime. Okay, my reference angles are going to be called theta prime. Since this angle is going into the second quadrant, it's not quite to 180 degrees. So whatever this is, let's pretend it's like 120. Okay, to get to my reference angle here, we take 180 minus that angle. So I take 180 minus 120, and I can have 60 degrees here. That would be my reference angle. Okay, so again, that's what we're referring to there. When I'm dealing with radians, I could just do pi to minus that. Here, we are going past the 180, so we're going a little bit further, which means whatever the theta is, so in this case, let's say it's like 200, then I could just subtract the 180 right here to get to whatever's left over in that spot. Okay, so that's how I can get to that one. I subtract theta minus 180 or theta minus pi. If I end up in the fourth quadrant, I'm almost at 360. So whatever that theta is, to get this reference angle, I'm going to take 360 minus theta. Again, it's very important to remember, we never use the y-axis to form a triangle. Any triangles we create have to be drawn to the x-axis. Okay, they're always drawn in that way. So let's find our reference angles for these couple of possibilities here. So I'll do a quick sketch of 330. I know the 330 is going to put me somewhere in the fourth quadrant. Okay, it's almost to the 360. So because of that, I'm going to take 360 minus the 330. That gives me 30. That means right here, my reference angle is 30 degrees. Okay, so that's the reference angle I'm looking for is 30 in this case. Negative 5 pi over 6. All right, so negative 5 pi over 6, I'm going to go the opposite direction. Notice it's not quite pi because that would be a negative 6 pi over 6. So that puts me in the third quadrant over here. So if I do that, draw that out right there. Okay, it's close is the idea. This is negative 5 pi over 6. So I got to figure out what this is. Well, the whole thing is 180. So I can just take pi minus 5 pi over 6. If I do that, then I get 1 pi over 6. So that's my reference angle right here. This angle is pi over 6. That's in that spot. Okay, when we talk about reference angles, we don't necessarily need to worry about positives or negatives. We're just referring to what angle do we create if we draw this as a triangle like that. So we get 30 degrees here, we get pi over 6 radians right there. All right, and that is all we have for today. So if you want to try this problem out, go ahead and pause it. But it's already drawn out as a sketch for you, and you can just find the reference angle right here. What angle is this compared to the x-axis and radius? Okay, but that's it for 12.3 day one. Take care. See you in the next one.